Sorry, excuse me. Using Java, I guess that would be the way you do it. Using Java in the command line sounds hard. Sounds like it would be easy for like a really simple project, but as soon as you have external dependencies, the build process gets complicated. And I think that would make the build process very difficult.
Is this loud enough for everyone?
I've done it with Maven before too in the pom.xml, and that was painful too. It was like, it was painful, but it kind of wasn't. It wasn't because there's just these huge blocks of configuration, huge blocks of XML that you just paste into your pom.xml. Then every tutorial is like, just paste it, it's fine, don't worry about it. And then it just works. But to actually understand what all that configuration is doing is, I don't know, I couldn't figure it out. It's just a very, like I'd have to read a lot of documentation to figure it out. Which I wasn't willing to do. It just works. Alright, well, guess I could check the Discord too. Can I still have Discord open when I have Twitch chat? Oh, sweet. Line of projector. How do you install IntelliJ? Well, I'll tell you next semester. Beginning of next semester, I'll let you know all about it. Alright, so let's continue with our tic-tac-toe game. We got a lot to do today, so let's try to get it all done. So I want to start with sharing this on GitHub. Let me resize this thing a little bit. Oh my goodness, is there one pixel where it's diagonal? There we go. Get this open. Alright, so what I want to do, and sharing a project on GitHub, really not too difficult when you're using an IDE like this. It's a little more difficult if you create your project in GitHub and then try to make a first push into that repo. It's not too hard. When you create a repo, it gives you the commands to type that'll do that for you. But with IntelliJ or any modern development tools, usually make our common jobs a lot easier for us. There's this share project on GitHub button. Who knew? Click on that, and then it'll ask you to log in. I'm already logged in. Hopefully I don't have to go through some credentials. Tic-tac-toe. I'll make it not private so y'all can see it. And I don't know. It's tic-tac-toe. And it's gonna ask me to commit. I'm gonna deselect all my idea configuration. I'm going to deselect that, so that's not part of the repo. You don't need any of that in the repo. I'm also going to ignore the IML. So you just get the code. So if somebody's cloning this into anything that's not IntelliJ, it's just the stuff that they actually need. And initial commit is good. Don't ask again. And project successfully shared on GitHub. There should be a link right to the repo. It'll be on my GitHub account because that's what I'm logged in as here. And tic-tac-toe. If you go to this URL, you'll see this exact code. It's the code that we've been working on in the previous lecture. So I've successfully shared that on GitHub. And if you want this code, you grab the link here, or apparently it does work up here, and then clone that repo in your project. So we got that one. So now whenever I make a change, I can go up here. These are my Git buttons. This is going to pull new changes off from the repo. So if somebody else makes a change to this project and I want those changes locally, I'm going to click this button, the pull. This is going to be the commit button, which is when I want to commit changes. I don't know how deep I want to go into Git stuff, but Commit is when I want to save my changes to my local copy of the repository, and then push, which is going to push it to GitHub, push it to the remote server. So if I want to commit this change, GitHub is going to figure out, or IntelliJ is going to figure out, and Git's going to figure out, I guess, what changes were made. Shows me a nice interface here, and then I can say, made a change. I don't have to be too excited about it. And then you can click commit, or you can click commit and push, which is usually what you want to do. Commit and push is going to get that all the way to the server. So I'm doing both of these buttons in one command if I select that from the drop-down. If you don't select that, you just got to manually push the push button. Now if I go back to GitHub, that change was made. I can see where that change is. And I can see that I have a change there. So as I'm working on this project, I'm going to keep committing and pushing my code. I want to undo this. I'm going to keep committing and pushing my code to get the latest code updated to GitHub. And then anybody cloning the repo, as I make changes, like if you clone it right now, run it, you can play with the game, and then at the end of lecture I'm going to push again, you can pull those changes. You can pull those changes and then get the latest code that I pushed to the repo. So that's your super short, in a nutshell, Git tutorial through an IDE. When IDEs have these buttons for you, it makes Git a lot easier. If you're using Git manually, without any GUIs, you're using command line Git, it gets, there's more to it. I don't recommend ever doing that, but some people swear by it still, so, to each their own. So if you're using a command line, there's a lot more to it. It's the same steps, but the IDE is doing quite a bit. IntelliJ is doing quite a bit for us behind the scenes, just dealing with kind of the annoyances of Git, just kind of taking care of them for us. All right, so let's get back to our code, and let's start making some changes. Let me push that change that I just did, undid that change, just so that's not part of our other changes. Push. And we're at the point where the front end is pretty much done. I think there's something I want to change with this. I think there's something I need to change. I was thinking about after the lecture, but the previous one, let's just kind of hack around and find out. So we have two methods as our API. Whenever a button is pressed, oh no, it's in the other lecture actually. There's something I want to change. The other lecture I passed a button in here, which I am going to need to do here actually. So we have the message that's going to be displayed to the user. Whatever this is what's going to be displayed. And I kind of rushed this at the end of last lecture. I think I was a little overtime when I finished up all this. So right now I'm, and the button that is pressed. So right now I'm remembering which button was pressed in a state variable. And then I'm displaying whatever the last button that was pressed was in the message to display. This isn't really something we want to do for tic-tac-toe, but it's something that proves that everything's working. And then in the GUI, I'm adding this event that says whenever the mouse is clicked, update the display. So messages, which is our text field that's going to display messages to the user, set its text equal to game.message-to-display. So every time somebody clicks the mouse, which is how they're going to be clicking their buttons to select X and O wherever, every time they do that, it's going to call this function, which is going to call message to display and display that on the GUI. And we have this running right here. If we click on a button, we'll get the index of that button as the last pressed. So that's where we're at right now when we want to add some features and actually make this tic-tac-toe. We actually want to make it the game. A few things we want. Let's collect some features actually. It's probably the best thing to do right now. So we want start with X's turn. It is, and we want some message. Let's say, take your turn X. then O's turn, and the message should be take your turn O. And that's our main game loop, just switching between X's and O's turn. And then our win condition. So we're going to check for our win condition. Either X wins or O wins. Or our tie condition. We filled up the whole board. It's Cat's game. And click to, and we'll ask the user to click any of the buttons to reset the game board. And that's what we'll listen to after a tie. So those are the 4 different things that we can see, and I guess our initial. We'll display the message, whatever we display over here. I guess the game doesn't care about that. It's set in the GUI. Initial, there's a little too many letters in that one. Alright, so that's where we're at with this. And we want to start building this thing. So whenever a button is pressed, actually we don't even want initial. Initial is take your turn X. Right? Take your turn X. So let's just create a few constants for these strings. X turn string. Of type string. O turn string. Take your turn O. X win string. And an O win string. And just like last time, by the way, in case it's not obvious, I'm making this up as I go along. I don't know if this is, it's not necessarily going to be the way to build this. This is just the way that I'm coming up with it on the fly. And then tie game string. Alright, so initially, I mean, it's just begging for the state pattern is the problem. It's really begging for the state pattern, but I'm going to do it with a bunch of flags and stupid stuff anyway. Alright, so var whose turn. So I need some variable that's going to keep track of whose turn it is. I'm going to make this a Boolean, I think, which I hate. You know what? I hate that so much I'm not going to do it. I'm going to make this a string so it's more clear. Starts at X. When a button is pressed, if this dot whose turn equals X, we'll do something else. Else, we're going to assume that it's O's turn. So if it's X's turn, we want to check if what was pressed is a valid move. If it's not a valid move, we don't want to do anything. We're just going to keep everything the way it is. So we need something to check if it is a valid move or not. And actually, we are going to need one more method in our API that I'll build in a quick minute here. So val game board. So I want to keep track of the state of the board, what's what's taken, or what's taken by X, what's taken by O's. So game board, which is going to be an array of string, is going to be an array of 9 strings, and they're going to be indexed the same way they are in our GUI. So we built these game buttons where 0 is the upper left corner and then so on. That's the way we built their indices for the game board. We're going to use the same indices for our game board here. So right now everything is empty, and then if X clicks on something that's not taken, if there's going to be a lot of conditionals. Seriously, it's begging for the state pattern to clean up all these conditionals that we're going to see. So if this dot game board of index, if it equals empty string, then we're go, else we're not going to do anything. And then you're going to put an else. It's an invalid move, nothing changes with the state of the game. So if it's empty, it's going to now equal X. We're going to check for win conditions. Actually, I think I want that to take a string too. And then this dot whose turn equals O. Just thinking about how I want to set this up. I want this here. Just check for wins. I'll change whose turn. Actually, I do want. So to be able to tell if there's a win condition, I'll change whose turn to something other than X and O. Else if, then else. And in this state, we want the game board. This should be a var. Guess it doesn't have to be a var, but I want to be able to do this. Switch to this, and then this dot whose turn. So if the game's over, so if the game's over and they click, I want to reset the game, reset the whole state of the game to be what it is. Actually, these strings, we want to say click to reset. Click to play again. And we want to do this same thing for O's turn. This is bad practice, generally accepted as bad practice. I'm cut and pasting code. I can make this generic code. It would take a little extra work that I don't know if I could fit in a lecture is the problem. So I'm going to reverse all these. And I'm going to set up my check for wins method. I'm not going to I'm not gonna implement this one yet, but I want to set it up just so I don't have those errors. So I'm going to take the player as a string. I'm just going to return unit. I'm going to use some OOP here, just change the state variables. I'm going to change whose turn to something else, something that's not, not whose turn. And I'm just going to leave this blank for now to do. And let's implement message to display. I actually want a map here. Fail string map. I think this is how I want to set this up. Is I'm going to set up a map that is going to map whoever's turn it is, whatever string is in there, and check for wins is going to set the whose turn string. I also want to check for ties, since I'm at it. And we could actually be a little, no, I want to keep it like that. This dot check for ties. This doesn't take anything. It just checks if everything is filled up here. Map. So whatever the whose turn is it string has, we want to set it to a separate string to display, which is going to be a map. This is to avoid a big conditional in here, by the way. We're going to say return this dot string map of this dot priest. What's up? You don't have a role in here? I thought you had a role in this channel. Whose turn? String map dot get or else. Whose turn? Now it should always have a valid value, so I'm just going to display error. Error if there's nothing. And then this map is going to store all of my mappings. So X turn string, O turn string, say X win. We'll do it all lowercase. X win for X win string. Y, I knew I was going to do that. O win string and tie. I really don't like the way this is all shaping up, but it's going to work, so there's one thing to it. And I need one more thing here. I need some way to get whatever strings are here onto the actual GUI. So I am going to need another API method. Def I guess just get game board. I guess it's just a getter. Yeah, it's just a getter. I guess I could access the variable directly. Let me put a getter anyway. Get game board was going to return an array of strings. And it's going to return this dot game board. I hate using get because I have strong opinions about this. I hate it. If you start a method with get, Scala wants you, or at least IntelliJ wants you, to remove the parentheses. And Scala allows methods with no parentheses, which, how do you specify if you're passing a reference to the method or if you're calling the method. You can't do that without parentheses. It drives me nuts. So here I want to expand this. So now I want another line to my method. So I'm going to expand this a little bit more using braces. And now I also want to get the game board. Game.get game board. For, so I want to do this. For I in game.get game board dot indices. I guess I'll go this way. I guess I'll do it this way. Buttons of I dot text equals game dot get game board of I. Yeah. All right. Marbles. I don't know if I have marbles set up. Is there anyone even from 116 watching this? Hopefully there are people in the room watching the projector, but I don't know if I'm building tic-tac-toe for anybody. All right, so let's restart this. We should be at the point where we can place X's, we can place O's, and play the game, but we won't have any win conditions. Like the game won't tell us if somebody won. So let's place X. Oh, we got some problems. And we can't, it doesn't check for win conditions or anything. What the hell are the problems here? Everything worked for what it's worth. Index out of bounds 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I just pasted one extra time. That'll do it. That'll do it when you have 12 things and you need only 9. Alright, so, I mean, we're almost there. We got a pretty good game. We're on track. We just need 2 things. 5 people in the lecture room. I see there's 5 on the stream. I'm hoping there's more in the lecture hall, or else I'm just kind of wasting my time here. 5 people. I mean, there were at least 30 who voted for this, who wanted to see this exact lecture. So I hope to God there's more than 5, or else people voted for me to do something and then don't even care if I do it. That's just frustrating. I choose to believe that that's not the case. So check. There's probably like at least 600 people in the lecture hall, right? So we're going to check for ties, but I'm only going to check for ties after I check for wins. So to check for ties, all I'm going to do is check if everything's not the empty string in this array. So I'm going to do this dot game board. Wait, do I really? Oh, never mind. Yeah, it's up here where I initialize it. Did I do it? No, I have to change it. That would have been a stupid bug to find. It works once. How come it doesn't work on the second game? This dot game board dot. I want to get fancy with this. I don't know what I have available to me in arrays, though. It looks like not a whole lot. I don't have like a fold. Oh, I do have fold. That's just not telling me all my options. I'll use fold left, fold right. I guess it doesn't matter which one. Just to be fancier about it. this to true, initialize it to true, and then give it a function that says that value and that what's the order here? I always forget the order. B is the second one. Okay. Is that because I did fold right? I want fold left, don't I? And that is blank. Apparently there's a shortcut for this. Placed with for all. Oh. I was getting fancier than I had to. I'll leave it as fold left because that's the one I knew how to do. Apparently for all is a thing. That's really handy to know, actually. So if you can read this one, I'll be impressed. Not overly so. We did cover it in class, but fold left, my accumulator is going to be initialized at true, and I'm going to say and each string is blank. So this is going to say is every, actually I got to make sure I'm doing this right. If every string is not blank, then this will be true. If even a single one is blank, this will be false. So if this, then this dot whose turn equals tie game. Nope, just tie. So now if we rerun this, we should be able to see our tie condition. But we didn't. I think I'm just thinking about this backwards, right? If they're all not blank, so it's true and that's not blank, and that's not blank, and that's not blank. Yeah, I just had it backwards. I was checking if they're all blank. Okay, and one more thing, just the win condition. This one's a little trickier. I think I'm just gonna code up every freaking one of them. So we have all of our different win conditions. This is where things are just gonna get bad. So 1, 2, 3, 4, 5, 6, 7, 8 different win conditions. I'm just gonna code them all up because screw it. So if valid lines is going to be a list of int, which equals a list of list which are, so these are going to be all of our valid lines. So 0, 1, and 2 is our first line across. 3, 4, 5, 6, 7, 8, and then 0, 1, 2, 3, 6, 1, 4, 7, 2, 5, 8 for our vertical lines, and then our two x's, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 4, 8, and 1, 2, 3, 4, 3, 2, 4, 0, 1, 2, 3, 4. I gotta make sure I counted these right. 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 0, 1, 0, 2. Okay, all that looks fine. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. Wait, I already did that one. 0, 1, 2, 3, 4, 5, 6. 6 is my last one. All right, so there's all our valid lines. Then I'm going to say for line in valid lines, I want that to be plural. If I'm going to use that new trick I learned up here, down here, wherever it was. If line dot for all this dot game board of underscore equals player. I'll make these capital just so I don't have to write two lowercase. Actually, no, I'll stick with this. It's a good example. This dot whose turn equals player dot two lowercase plus win without an S. Okay, so we're going to check all the valid lines. That's not as bad as I thought it would be. That's not too hard-coded. Then we find out that person wins if nobody, okay, I mean, everything checks out here. We might be done as long as this works. What? X wins, resets. Take your turn, X. O wins. Ladies and gentlemen, I think we got there. It wasn't too bad. All right, so there's one more thing I want to do now that we built tic-tac-toe. It's not too hard to build tic-tac-toe. This could make a good homework assignment, right? It's not too much. I mean, my code came out pretty clean. I'm sure this wouldn't be quite so clean in student code if I had this as an assignment. You know, given an array with indices 0 through 8 that represent the game board as thus and label them and everything, check to see if somebody won. It wouldn't be too bad of an assignment, right? I don't think it'd be too bad. So the last thing I want to do, let's push this actually. It's done, yay, it's tic-tac-toe. No errors. I'll review a warning. Oh, yeah. It just wants me to collapse that. Push. Alright. Last thing I want to do. That's exactly what I want to do, actually. Icore mosquito. That's exactly the next thing I want to do. So I'm glad you asked. So what I want to do now is package this up in a program that somebody without IntelliJ installed on their machine, which, as it turns out, is most people in the world, can actually play this game. To do that, my magic keyword is going to be executable jar. I want to build an executable jar containing all the contents of this package. Hopefully this doesn't crash and burn, because I haven't done this in a while. I'm going to go to Project Structure. This is where we go to set up our JDK and our SDK. We've done that at the beginning of the semester, so you had to do it like for each project and things like that. Right now we want to go to Artifacts. I'm going to add a new artifact as a jar file. I'm going to select from modules with dependencies. It's very important that I get all the dependencies in there. So everything that was downloaded with this pom.xml, I want to package all of that code, all of that compiled code, Java bytecode, into one file. So it's going to ask me one really important question: where's the main class? So in a Java project, you can have multiple classes, or rather multiple objects, classes in Java, but which is why the interface is saying main class. But what object, you can have multiple objects that contain main methods. So when you package your whole project into one file, it's going to need to know which main method to run, and I want the GUI. That's where you run this program from. So if you have multiple, here we only have one main method in the whole project, but if you have multiple ones, make sure you select the one that people are supposed to use to actually run your project. Extract to the target jar, sure. Copy the output directory and link via manifest. Sure. I don't remember what that means. Hopefully that doesn't screw me up. And I'm gonna do that. Okay, so I got my jar set up, and it looks like it's getting all my libraries that I need. That's good. And then I'm going to build the project. It's actually going to compile everything and give me my final compiled jar file, which should show up in this target. Like, you can always go in here and look at your class, like your compiled code. So it's not showing it compiled. But you can go in there and look at your compiled code, but we should have an extra thing. You might just be thinking right now, build. Doesn't seem to want to build. Build artifacts. Ooh, that's what I want. Yeah, build my artifacts. I guess it makes sense why that would be separate. You don't always want to build your artifacts while you're developing. Oh, and we got it in, sorry, not in the target. It's another red directory out, which gives me this tic-tac-toe.jar. Now, if I'm lucky and everything works, I should be able to grab this jar. I should be able to grab this jar. Let me throw it anywhere else. And double click it. Oh no, then it doesn't work. Come on. Piss off, man. Oh, is it just going really slow? Maybe it just takes a while for the JVM to load this, load the dependencies. Could that possibly be? Could that possibly be a thing? There's no reason. There's no reason for this to be that laggy. But anyway, the executable, aside from performance issues here, the executable jar runs your whole program. Any computer, any machine that's running a JVM, which is just about every one of them, is going to be able to double click on this jar and run that code. It runs right on the JVM. I think it's not. Okay, I want to try to debug this. I think it's not getting my mouse event properly. What if we do an action timer? I don't remember how to do an action timer though. I closed my IntelliJ over there. Where do I use an action timer? Guess I'll just ask the internet. It looks like it's not capturing my mouse clicks. Why aren't none of these saying action timers? Oh, yeah, good call. Here, let's fix that bug while I kind of think about that. Yeah, because check for ties happens regardless of the check for wins. So if, I mean, there's one really bad way to do this. If whose turn that contains win not. Folks, never push your bug fix without actually testing it. I didn't even run the GUI. Just a pro tip there. Don't do what I just did. Let me run it just to make sure that bug doesn't exist. I should have used that as an excuse to show like debugging, like recreating the bug and all that. Yeah, there we go. But yeah, check for ties, even if somebody won, and checking for ties just was if nobody won. I want to do the action timer for the other lecture too. I do want to figure this out. I know I've used one before. I can't think of which repo I did. Jumper. I know where. I didn't even talk about Jumper this semester. It's kind of sad. Action timer of update, start, update. Is this the method? Is that really all? Action timer. Animation timer. That's why I couldn't find anything. It's an animation timer. Which takes our function. So the animation timer, I should be explaining this more. The animation timer is going to call this function once every 60 seconds if it can. Unless that function takes too long, then you start dropping frames and you don't get your 60 FPS. But it's going to try to get 60 FPS. It's severe overkill for this, but I want my jar working, damn it. Open in Explorer. $350, so that's new. And we have our executable jar that actually works now. So let me push that change. Change from mouse clicks to animation timer. Fix bug. And running from jar. Yeah, I think we did pretty good today. We even debugged a pretty tricky bug. A bug that only appears in the jar, but not when running in IntelliJ. That's the stuff nightmares are made out of. And we even got through that one, so happy about that. And we got our game. You know, we built tic-tac-toe. Nobody's gonna tell us we didn't. We built it. We talked about Git. I didn't talk about Git too much, but I mean, I covered the things I wanted to talk to. Push, pull, commit, clone. We've seen all semester, but no problem. Pushing, like if I could do a lot more about Git itself and set up, like if I had more time, I would intentionally set up a merge conflict. I'd clone the repo twice, push in one, and then pull in the other, and then push from both, set up a merge conflict, and resolve that. But when you start using Git, you'll come across that soon enough.